When it comes to validation, I'm sorry if I'm asking this question again. I'm sure there is not this kind of convergence thing that we discussed. But how do you validate such a tool? What are the techniques that you use? I mean, for FEA, there's this common patch test. For CFD, there's maybe something like this famous backward-facing step. What is this one validation case or validation cases in SPH that someone can use to see if the tool is really giving valid results?
Okay, so maybe interestingly, so we have 3 pillars at FIFTY2 which are the main focus of our work, which should help us to realize what we aim for, which is usability. We have covered it. So Brion Lab is an all-in-one tool. We have efficiency, which is the other pillar. And the third pillar is reliability. So there we focus on validation and, of course, making the software robust, because with every change, and we are progressing or developing it in a rapid pace, there's always the chance to introduce regression to the code, right? And so reliability is very important. We have a lot of different a big test suite which is growing. And finally, now your question goes to how do you validate this code? And this was always a long question, because where Brion Lab or particle flows in general are very good, which I mentioned earlier, is in free surface flow computation. Now go and find what the literature says about free surface flows. So the most cases are internal flows that you will find from a CFD point of view. And for free surface flows, and especially when it comes to not pressure-driven flows, but flows that are showing microfluidic behavior, there you won't find that many. I just saw recently that you posted something about the Torricelli case or Bernoulli case. This is one of our validation cases. There you can really analytically pre-compute what the solution should be. This is tested, but this is pressure-driven flow. And then there are a lot of, we have oscillation droplet to see that the frequency which a droplet would oscillate in space is really matched by our cohesion model. Then we have this famous marine dam break example, which is also pressure-driven flow, where they have also pressure forces that are measured in the real experiment. This we have also publication on. And then there are a lot of customer-driven validation cases where the customer did some really they put some effort in to build up a benchmark for free surface flow computation for water, especially because they don't find much in the literature. So very often we face that the customer has their own set of benchmarks, which are either really related to the application or just on a more general level. If you go to our homepage, you find something where we have a flow coming, an impinging jet, and then this hydraulic pressure jump is on the top, and then there's a flow running down a plate which is inclined, and there are cylinders on the bottom which the customer measured what the simulation predicts and what the experiment says, and there we are in very good agreement. And this is one now of our test benchmarks as well.
Very
but it was a lot of work that we and our customer put in to build up this validation suite.